Today we learn how to find HCF or GCD using prime factorization method. HCF stands for highest common factor and GCD stands for greatest common divisor. HCF, that is highest common factor of two or more numbers, is the highest number among all the common factors of the given number. If we are finding the common factor of any two or three numbers, whatever the highest number which is common among them will be the highest common factor. There are basically three methods to calculate HCF, that is listing factors method, prime factorization method, and long division method. In this video, we'll learn how to find HCF using prime factorization method. We have already done listing factors method. If you haven't watched that video, I'll share the link in the description. You can watch it. Now, HCF by prime factorization method. There are some steps. So for first step, write each number as a product of its prime factors. So we'll write the number as the product of prime factors, and this method is called prime factorization method. Now, what are prime factors? Before that, you should know what are prime numbers. Prime numbers are the numbers which have only two factors, that is 1 and itself. If you haven't seen my factors video, you can see that. I'll link below in the description as well so that you can watch that video too. So when we are finding the factors of any number, if it has only two factors, that is 1 and itself, then it means they are prime numbers. Now, in simple language, we can say that if any number does not come in any other table, it only comes in its table or in one table, then they are prime numbers. So it doesn't come in any other table other than him itself. So suppose example, we have 2. 2 does not comes in any other table. It comes in itself and 1. So 2 is the prime number. If we'll go to the other number, that is 3. 3 is also a prime number because 3 does not come in any other table. And what about 4? 4 come in other tables. So 4 is not a prime number. It's composite number. 5 again does not comes in any other table. So 5 is a prime number. 6 again comes in 2 table, 3 table, so many tables. So it means 6 is also not a prime number. So prime numbers are those numbers which have only two factors. It means they are not coming in any other table than themselves. Now let's see an example. The first 30 prime numbers I have written here, it's better to learn them, or even you can easily know that after 2, 3 comes, 4 comes in other table. So 5 is the prime number, 6 comes in other table, 7 is the prime number, 8, 9, 10 comes in other table, 11 is a prime number, 13, 17, 19, 23, 29. So these are the prime numbers. We always use prime numbers while using the prime factorization method in HCF. So remember this, prime numbers are always used. Now, after finding the prime numbers, like if you have written the number as the product of prime factors, then you'll list the common factor of both the numbers. Whatever the numbers are, if even it's 2 numbers or 3 numbers, you'll find the common factors. Then you'll do the product, means multiply all the common factors and you'll find the HCF. So simple step. First, you'll write the prime factorization of all the numbers, just whatever you need to find the HCF. Then you'll find the common factors. After common factors, you'll do the multiplication of all the common factors and you'll find the HCF. So first prime factorization, then common factors, then product of the common factors. Here you're not finding the highest one. It's in the listing method. Now let's see an example. Find HCF of 14 and 28 by prime factorization method. So first, prime factorization method is like this. We'll draw a vertical and the horizontal lines. So for 14, I'll write 14 here. Now what I'll do is I need to check 14. First, I'll start using the prime numbers only. First prime number is 2. So I'll see where 14 comes in, like 2 table 14 comes. Yes, it comes. So 2 will be written here. 2 table 14 comes, but where it comes, we'll write under 14. 2 sevens are 14. This way we do this method. 2 sevens are 14. Now we'll check 7. 7 comes in 2 table? No. Comes in 3 table? No. So we are just checking the prime numbers. 4 will not check. 5 table? No. 7 itself is a prime number. So 7 will come only in 7 table. So we'll write 7. Where it comes, it will come down. 7 ones are 7. So your motive should be at the end, you need to leave 1. Now the second one. So we finished with the 14. We have got the prime factorizations of 14, that is 2 multiplies 7. Now we are going to find prime factorization of 28. Now we'll write 28 first. Now we'll again check in 2 table 28 comes yet. Yes, it comes. It's an even number. So where it comes to a 2, we'll write 2 here. In which table it comes. Like 28 comes in 2 tables, so we'll start writing 2 here. Now where it comes? 14. 2 14s are 28. Now 14 comes in 2 table. Yes, it again comes. So we'll check again and again. So it comes in 2 table again. Where it comes? 2 table, it comes at 7. So we'll write 7 down. 2 sevens are 40. Now 7 is a prime number. It will not come in 2 table, 3 table, 5 table. It will come only in the 7 table. So 7 ones are 7. We are done with 28 and we are done with 14. So we'll write the prime factorization of 14 first. That is 2 multiply 7. We always write the prime numbers, which we write this side. Now prime factorization of 28 will be 2 multiply 7. Prime factorization of 28 is 2 multiply 7. Now we'll write the common factors. Common factors mean which are common in both. So 2 is common both in 14. Prime factorization also 20. We'll write 2 here. 7 is coming in both, so 7. Now HCF will not be highest. HCF will product of the common factors in prime factorization method. So 2 sevens are 14. So your HCF will be 14 here. Now we'll moving to the next example. Now we will find the GCD. GCD is just the HCF only. We'll find the HCF only. So HCF of 21, 36, 15. Now we have the three numbers by prime factorization method again. So first we'll write 21 in this block. I have written 21. Now I'll check 21 comes in 2 table because prime number starts with 2. So 21 do not comes in 2 table. How I know? Because I know the divisibility rule of 2. It should be even number or it should be last digit should be 0, 2, 4, 6, 8. It will come in 3 table. So I'll write 3 table. 3 sevens are 21. 3 I'll write where it comes. It will be come down. So 3 sevens are 21. Now 7 is again a prime number. It will not come in any other table. So 7 ones are 7. So 1, it means we'll end here. Now the 21, we are done with the prime factorization. That is 2, 3 and 7. 3 multiply 7. Now I'll write 36 in the block. Again check. 36 comes in 2 table. Now how you'll know? It is even number. Or if the last digit is 0, 2, 4, 6, 8. For this, you need to learn the divisibility rules as well. I'll share the link in the description for divisibility rules so that you can remember the rules. So 36. 36 the even number, it will come in 2 tables. So I'll write 2 here because it's coming in 2 table. Where it comes, it will come down. 2 table where if you do not know, you can divide. Divide 36 with 2 and you can write the answer here. So it come at 18. 2 18s are 36. Now 18 comes in 2 table again. Yes, it comes. So I'll write 2 again. Where it comes, 2 9s are 18. 9 will come down. Now we are with 9 here. Now check 2 comes, 9 comes in 2 table. No, it will not come. So we'll check for 3. After 2, the prime number is 3. 3 or 9 comes in 3 table. Yes. So 3, where it comes, 3s are 9. Now again, we do not have 1 still. So 3 is again a prime number. So 3 will not go with 2. 3 will go with 3 only. 3 ones are 3. So we got 1 here. So 36 prime factorization is 2 multiply 2 multiply 3 multiply 3. Now we'll write 15 here. Now 15. Let's check. In 2 table, no, it will not come. 3 table, yes, it will come. 3 5s are 15. We'll just check the prime numbers. So 3, where it comes, 5s are 15. Now 5 will not come in 2 table, not in 3 table. 5 will come in itself table, that is 5. 5 is a prime number. So 5 ones are 5. We got the prime factorization of 21, 36 and 15. Now we'll write the prime factorization. Prime factorization of 21, that is 3 multiply 7. Prime factorization of 36, that is 2 multiply 2 multiply 3 multiply 3. Prime factorization of 15, that is 3 multiply 3. Now we'll check what is common in all these. It is 3 is common in all of them. So we'll just write the one number. It can be two numbers, but we will check only that numbers which are coming in all the three numbers, like 21, 36, 15. It should be common in all three. So it is common factors here is 3. So HCF will be only 3. And what if you'll get a question and there is nothing common? Here is 3 multiply 7. Here is some 8, some other numbers. Here is some. If there's nothing common, then you'll not write HCF 0. So HCF will be 1 if there is nothing common. So you should know that they are called prime numbers, but you should know if there's nothing common in all the prime factorizations, the HCF will be 1. It will not be 0 because 1 is coming at the end of every prime factorization. So HCF will be 1, not 0, even there is nothing common in between. Now this way you can find HCF and GCD. It's very easy. If you do not know how to find prime factorization, you can write in the comment section. I'll make a separate video for the prime factorization method, how we do the prime factorization. If you understand here, it's better. Fine. So it's your time to do some workout. Pause the video, answer this in the comment section. I'll check the question, which numbers are used in the prime factorization method that I have already explained. Okay, thank you for watching. Please subscribe and like, and don't forget to hit the bell icon to get notifications for our upcoming videos. Thank you. Bye-bye.